All right, let's go ahead and get started. It's 8:30. Welcome to Wednesday morning at SDC. And I'm Joseph White. So I'm the OPI Technical Steering Committee Chair and a fellow at Dell. And I'm going to be talking about the Open Programmable Infrastructure project. So here's the abstracts we submitted. It's got lots of fun words, but we'll show some diagrams and talk about some concepts and talk about where we are and what our challenges are. All right, so why do you care about OPI? Why does it matter? Well, with Moore's law slowing down and the rise of new problems that require a lot of acceleration, you end up with infrastructure that's disaggregated, distributed, and then aggregated logically and then virtualized down for multi-tenancy and to run multiple jobs. You get heterogeneous compute. You have, GPUs, you have variety of CPUs, you have multiple processor families, lots of silicon diversity. You need composition, isolation, better ways to manage that infrastructure. And hosts need specific kinds of acceleration and virtualization or remote resource allocation that depends on exactly what job they're doing right now. Hyperscalers have been deploying these things successfully because they were the first ones to see this shift in infrastructure. And there are a lot of papers out, and there's a lot of information that says that DPU and IPU are good for solving these problems because they provide a separate platform on which to do the acceleration and that isolation boundary. And we need basically better efficiency. Now, what's the problem? So the problem is if you have a half dozen DPU, IPU vendors out there, right? And so we have 3 major ones or 4 major ones, depending on who you are and how you count, and another half dozen or maybe more startups and variants of DPUs. So if you start introducing SoCs that are made out of chiplets, you're going to end up with these DPU-like things that aren't quite the standard definition of DPUs, but they've got all the same properties and all the same issues. What do you actually need to do? Well, what you need to do is have standard APIs, okay? Because you'd like to mix and match your set of DPUs and IPUs to match the job you need. And as things evolve over time, you don't want to have to rewrite all of your control plane infrastructure constantly, okay? So what did we do? So we got together a number of companies to try to solve this problem, to try to create common APIs across DPUs and IPUs, okay? And so you can see we have 10 premier members and another 5 general members, and it runs the spectrum of the companies you would expect, which is the major infrastructure vendors, a few telco service provider types, and then the DPU vendors, DPU and IPU vendors, all right? So I've already said what the goals are. We want to create common community-driven standards. We want open ecosystems and open source. Vendor-agnostic frameworks and architectures for the software stack. So we want the hardware to be differentiated, right? Because all the vendors want to produce hardware that's compelling to the customer segments they've identified. But if the APIs to drive the software on those things is different, then we're going to have long-term problems in the industry. We want to reuse existing APIs where they exist. So if I've already got Redfish for system management, why would I want to try to reinvent Redfish just for DPUs? I wouldn't. If I've got networking APIs, do I want to fully reinvent or do I want to adapt and use? If I have system provisioning APIs. Do I want to adopt them, or do I want to try to drive a brand new standard? Now, there are places like storage virtualization APIs where there isn't a lot that's common, and there we're trying to do direct new things. And then to show that this stuff works, we need implementation examples, some reference software reference architectures. Okay? Now, so what's the model? So you guys are probably all familiar with DPUs and IPUs, but I'll go over the model and where the line is drawn and what the hardware can do for you for background and to make sure everyone's on the same page. So the traditional SmartNIC model is I have a little bit of hardware offload. I might have just encryption, for example, or I might have a little bit of queuing and traffic engineering, or some RDMA support, Rocky or like that. And really the main server runs that infrastructure. Okay? I have traditional drivers, I have traditional stacks, and so on. In the DPU IPU model, you offload more of that functionality into the NIC itself, into the data processing unit. And when you do that, you get efficiency, so you get more ARM cores. You get a boundary on which you can say we have a trust line. So you can lock your DPU or IPU down more than you can your server itself. And you can then, the server administrator doesn't have to worry about that stuff. And the overall system administrator has a lot more confidence in the infrastructure. I also get more hardware pipelines, more hardware offload, programmable offload in some cases, in which to optimize data flows in and out of that server. And because I have this completely separate subsystem embedded in the server, I can, again, use it to virtualize remote stuff, file systems, block storage, object storage. I could virtualize remote GPUs. I can handle multi-tenancy better. I can have a more sophisticated hardware root of trust. So some BMCs do some of these jobs, but they don't do all of the offload and acceleration at rate. So DPUs and IPUs today are 2,500 gig sort of mainstream, but they're rapidly, starting now and going forward, they're going to be 400 and then 800 gig. The ARM cores have been limited so far. You've sort of in the 4-ish ARM core range. Upcoming, you're going to get 16 to 24. And then in some cases, you're going to have grids of them that you'll get 32 up to maybe 256 ARM cores, right, in a very different kind of architecture. That's going to really open up, that really opens up the design space for what these things can do for you. And the power, the power and cost are modest, right? So power's, 50 to 100 watts. And that's not nothing, but it's tolerable. Okay, so what does a DPU look like inside to, again, further anchor the discussion? So it's got, so it's a card. It can be deployed as an SoC. Again, if you embedded it in a switch or some other appliance, you could just use it as an SoC because they're basically built as ASICs or a small set of ASICs. But normally it's a PCI card, so it's got a PCI interface. It's got a PCI switch embedded. Typically they can be root complexes. They often have independent BMCs, so they can act as a BMC for themselves as a microserver, and they can also act in principle as a BMC for the hosting system. It's got embedded NIC function. So most of the DPUs and IPUs out there can just act like a NIC. I mean, you couldn't tell the difference. Packet rates are the same. In fact, sometimes they're built on the same exact silicon. the same exact intellectual property blocks. Then I have memory, and sometimes there's even high bandwidth memory, and then an array of ARM cores that I talked about before. So again, 4-ish was true yesterday. 16, 18, 20 is true tomorrow and in the future. And then, there are limits in the real estate you can have for a given power, but if you've got 16 threaded ARM cores, you can do a lot of work. And then often you have a network switching offload and multiple interfaces. So again, the interfaces vary from 2 to 8 for in terms of the MAC addresses and embedded interfaces. And the embedded switching capability, varies quite a lot as well. At its most advanced, it can basically do a full network switch with full ACLs and full packet forwarding. This lets me terminate layer 3 directly in my server. The advantage of that is I can do my tunnel termination in my server, which gives better scaling and more flexibility. Because if you do it at the switch, you're limited by the switch management CPU and the switch capabilities and table sizes. Here I've got a set of tables and tunnel termination per server. And in fact, not just per server, per DPU I put in the server. And that can be very powerful if you're trying to build a complicated large-scale overlay system, for example. Running routing directly into your server lets you do ECMP, lets you get out of a whole bunch of layer 2 Ethernet mess. Okay. Then you typically have an encryption block, typically lifted from a performance NIC side, but it can do more than that. It could do key generation, regular expression matching, it can do hashing, it can assist deep packet inspection. And finally, you typically have some form of embedded cores and or P4 pipelines or the equivalent, sometimes an embedded FPGA function that let you do protocol acceleration. So think if you want to run NVMe over TCP quickly, and you had an embedded pipeline that could handle stateful session transactions. That's very powerful, because now you can get all the advantages of TCP with none of the downsides in performance. So what use cases do you put these to? Well, I've alluded to a bunch of them. DPUs, IPUs apply across edge, enterprise, cloud, and telco. And for the telco, it applies both at the core and the edge. Okay? To service these areas, we need infrastructure workload isolation, hypervisor assistance, security assistance. Again, I talked about network offload. Again, I can get TLS. I could get TCP, TLS, NVMe over Fabric, all in one pipeline, all in one stack. Okay, that right there is powerful. If I was going to virtualize a GPU, I could handle all of the GPU multi-tenancy without the GPU having to really know that that's happened, other than he's got partitions. So it's kind of a powerful story. And I could repeat the same thing for pretty much any segment we're dealing with. Now, that makes these things a little scary because you need to be able to manage them. And that management story is, again, why OPI exists. All right, so what did we do? So we organized ourselves into provisioning and lifecycle working group, an API and behavioral model working group, a developer platform working group, and a use case working group. And what we need to deliver is open source projects. And this can be done piecemeal. So the good thing and the bad thing about DPUs is because they're many servers, there's lots of aspects to them, and you can do them piecemeal, or you could try to do a big unified release. Right now, we're at a transition point from doing piecemeal, and I'll show you some of the things we've already done, to trying to figure out how we have a release that somebody could pull down and load. And if I have a vendor DPU with the vendor SDK on it, then I should be able to pull down OPI, load it up, and run it. And that's our next big step for OPI. We also realized we probably need to produce a couple of specifications and standards. The big one right now is basically a boot PCI bus behavior standard. So DPUs are not uniform in the way they behave inside a server, and the qualification cycle is a little bit harder than it should be. And we think if we come up with common approach for how to deal with this, we can win that game. And so the lifecycle and provisioning group has been working on this for a while, and they're developing on an active proposal for that one. But do we need to standardize? Do we need like these big comprehensive soup to nuts architecture diagrams and try to constrain everyone to that? We haven't found the need for that so far, but I'm not ruling it out in the future. Reference platforms. So we need examples of running OPI code, both emulated and, again, directly on hardware. To that end, we're actually building out an OPI lab. So we have Hurricane Electric as our lab space provider, and we have equipment incoming. So we should see the first instance of our lab come up within a couple or 3 months. And we're going to start by taking the code we have and the examples we have and running that. And I'll show you a few of the examples. And if you're around later, you should listen to Dan Daly from Intel, who's also a technical steering committee member, talk about details of some of the use cases and examples that have been developed. Obviously, if you're going to have a bunch of software that's supposed to work together, you got to have your test suite and test cases. All right. So the scope of each of the groups. So provisioning lifecycle is what you'd imagine it is: discovery, inventory, boot, lifecycle and updates, monitoring and telemetry. Right? All the things that go into making the thing just run. The API and behavior model cover everything else. In particular, we need networking, storage, and security as our primary APIs. Now, whether we should do things like VPNs and firewalls and standardized APIs there remains to be seen. So the API working group has alpha definitions, and they're working on making those beta definitions and really putting them to work. Okay, so we do everything through GitHub. Plus, we have a Linux Foundation webpage, but we do most of the work through GitHub. Here's a little schematic of the OPI repositories, and you can see that each of the working groups has a core repository, and then each of the sub-projects has its own repository. So you can see we have strong Swan for IPsec, we have secure ZTP for code upgrades, we have SPDK bridges to the major vendors, and also SPDK for CSI, the container storage interface, because mapping the behavior of DPUs into the behavior of container systems, in particular Kubernetes, is critical. Because as infrastructure goes forward, if you can't integrate well with the container world, you're not going to be very successful. We've agreed that OTel should be the common telemetry framework. Again, the specific telemetry, we decided to punt on whether we have a common telemetry model so far. That's a discussion that'll be upcoming, but we've got OTel as the framework, which isn't nothing, right? So again, if you have a common framework, at least somebody knows how to tool for it. And then We've got some SM BIOS for discovering the components on the cards themselves. All right, so there are commits that have been coming in. This goes through June of this year, and it's some momentum, some progress. It's not over the top fantastic, but given the situation in the world the last 15 months or so, it's not bad. We're starting to see increased participation and contributions across the companies. Okay, so let's look at the details of each of the areas. So storage, network, security, AI/ML, telemetry, system and lifecycle management APIs. The idea is to have an API gateway, to dispatch to all of those, and to use gRPC definitions for the API access itself. And then underneath the covers, you translate to the local API. And we have a diverse set of target use cases. So you got to have data center, you got to have on-prem and public cloud, 5G cloud, K8s clusters. The most important ones are the networking and storage. Okay. So this is a little schematic of the mechanism for dispatch. I won't read this one to you, but it's got all the pieces you might expect in terms of just a kind of a software framework, software architecture, if you were going to do an API gateway with dispatch for gRPC. For the storage API, there's a reference implementation ready. So it maps the OPI APIs to SPDK, and as you saw from the repository map, the SPDK is then mapped into the SDKs on each of the vendor's cards. And the example has CI/CD integration, and you can go and pull this down and build it and run it today. And essentially sets up the mapping of the storage into the host system. For the networking API, there was a meeting yesterday morning where they got a lot closer to defining what it is we're going to do, because you have Sonic out there as open source networking, you have OVS as open source networking, you have ITF models, Yang models, you have open config Yang models, you have Redfish networking models, and that combination, and then you have the container networking interface, and that combination presents a lot of challenges for how you deal with networking, and no one yet has ever come up with a perfect answer, right? So all of the answers have, and again, this has been going on in the industry for, I don't know, as long as I've been in the industry, and all of the answers end up devolving to a lot of vendor-specific stuff, no matter how comprehensive and how complete the standards are. It just is a fact. Look at the history, that's what's happened. So, but DPUs are going to be layer 3, objects. They're going to be IP endpoints but not just IP endpoints, they're going to be multi-IP endpoints. They're going to run BGP. They're going to provide switching for your containers and your VMs in hardware offload. They're going to provide front-facing switching. They're going to provide tunnel termination. They're going to provide ACLs. Doing all of that lets you do distributed firewall in a much cleaner way. So we have some ideas about how to deal with this part of the world. They're not complete yet, so I won't tell you what the answer is, but if you have any interest in networking APIs, then come join us and help us finish the definition and come up with the right answer. Okay. So there are some, EVPN, IPsec, a little bit of multi-tenant for public cloud, reference implementations out there. We have vendor support that's mixed across the DPU vendors. So there are steps that we can show things that work, but that core layer 2, layer 3 I'll call it a micro switch, is interesting. And again, the main focus of the API group now is to solve that problem. And here's just an example of the multi-tenant public cloud and what the structure is. You'll see the term XPU. So in the code, we sometimes use little x, capital PU, even though capital XPU has been used by at least one company for other kinds of devices. This was an early attempt to not have to put DPU, IPU like everywhere, especially for code. Terminology is a mess here. The terms that have settled out are, again, data processing unit and infrastructure processing unit. And so an OPI uses both terms. But, SmartNIC Summit uses the term SmartNIC. And when people say SmartNIC, sometimes they mean a performance NIC with some offload, and sometimes they actually mean a DPU. And again, the lines, when you get chiplets and custom SoCs out of chiplets, the lines are going to blur even further. And those have already been talked about in the industry. Those are coming. Okay. So here's another little schematic just showing the structure of the EVPN gateway, and what's done on the P4, what's done on the ARM cores, what's done in the host, and how it's glued together. Again, these are, each individual one is not super complicated. When you start taking the aggregate of all of them, it gets more complicated. So we have a number of demos that are recorded, so you can reference these from the webpage. There's networking cloud demo, IPsec demo, storage demo that you can reference. The APIs are referenced. The client code that uses them is referenced. All right, and then we have some POCs. So I'm going to explain, show you just a couple of examples. Dan Daly is going to go through more examples in a later session. So the F5 team is doing an Nginx POC just to prove that you can take something like Nginx, drop it onto DPU and run it using the OPI APIs. And this should be easy. And if it's not, then we need to make it easy, because this sort of porting effort ought to be, very straightforward. And here, here's actually the components. So an Nginx proxy on the DPU is the key thing, right? So you split the functionality, you accelerate the parts that are that would benefit from having extra cores, faster lookup. And, again, the concept is straightforward. Again, the devil's all in the details for IPUs. So again, having a microserver sitting on my PCI bus, that's also my NIC, straightforward concept. All the ways you can make use of that make it tricky, right? And so the other thing that you have to realize about DPUs is there's no single application that justifies them. Not really. But if you take a number of the things they can do and put them together, they become extremely valuable. So why do the big clouds all tout them? And why are they buying them in droves? The DPU industry exists because of the public clouds, the tier one public clouds. It's because they've got 4 or 5 different jobs to do, and they like this idea of isolation. And that value should trickle down to enterprise. Again, OPI exists because we believe that value trickles down is the right word. It's going to hit enterprise and telco, because in fact, most servers are running mixed workloads, or if they're not running mixed workloads, they're running jobs that require mixed acceleration. And this is true in the GPU world. This is true in the storage networking world. This is true in the hypervisor offload and management world. We have examples that this can work out there. So, there's, VMware has DPUs that you can get that offload ESXi and NSXT, and they can show it works, and they can show a value proposition there. NVIDIA has examples, and they talk about the value of GPUs to the various workloads that they care about. Intel has examples, and they talk about the value of DPUs to their workloads. Marvell has a presentation coming up in this track later this morning where they talk about, hey, here's an offload example and how it works and why it has value. So, the current generation of DPU, again, upping the ARM cores and upping the hardware offload capability and getting more open software that can run are the keys to unlocking this value. And there are a lot of references here for OPI. There's opiproject.org. There's a GitHub. We have discussion lists, and we have Slack, and we have a YouTube channel. So we have all of the kind of modern project resource access. There's no cost to actually join and participate. If you want to be a voting member, obviously, there's a Linux Foundation fee, but you can come participate, you can come listen, you can all of the information is open except for the board meeting. So the TSE calls are all open. We welcome any input, any examples. We welcome counterpoints or arguments about pretty much any topic related to DPUs and IPUs is open for us. All right, so questions? Thoughts, questions? Anything at all? Even if you're already a member of OPI. Yes, sir. So right now it's mostly how you map into the host, because on the target side you would use whatever your file system is, or NVMe over Fabric offload. But so the sort of the storage networking side out from the DPU is well defined. So there are standards there, with nvme.org that cover that very well. So this is mostly about how you present. All the APIs are pretty much about how you present the storage into the host. And there weren't really good examples of how to do that, especially from something like a DPU that presents multiple virtual functions into the host. So that was the first part of the problem we tackled. Now, whether or not for the container storage interface, if there are more sophisticated things we can do, I believe there are. And we haven't done that much of that yet. There have been some thinking, a little bit of work, but we haven't really finished that one. And then how you would tie in to all the existing remote storage in a clean way. There's work we could do there. There's improvements we could make there. But, yeah. All right, other thoughts, questions? Yes, sir. Yeah, back-end API for storage. But I think we have a room for enhancement and improvement there. Yeah. 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 We have, again, for later talks of this track have we'll show more detailed examples of this stuff. Anything? Yes, sir. Yeah, so the security stuff we've done so far is mostly focused on IPsec and TLS. and getting that running, so to secure the traffic itself. What we've talked about is that we need a multi-tenancy authentication model so that multiple users can access the DPUs in parallel. But we don't have a lot of detail on that one right now. It's mostly been focused on securing the traffic into and out of the DPU. So again, the certificate exchange and things like that is mapped out, but how you really handle multi-tenancy on a cluster of DPUs is a future step. And if you have any thoughts about how that ought to be done or what the use case is, then come participate. Come say, hey, here's what we need, or here's how we think it should be done. We definitely welcome that. Other questions? Or again, if you're already participating, observations are fine as well. Yes, sir. Computational storage. So there is an overlap with the concepts that are in computational storage. And from a SNIA perspective, using DPUs as a component of the CMSI and the computational storage would be valuable. They're sort of a natural adjacent technology to the on-storage computation, and sometimes they are the on-storage computation. So if I built a box that had, 32 to 48 drives, or maybe 40 or 44, and I dropped DPUs in as the head end for those, dropped a couple of DPU chips in as the head end or a couple of cards, then I could say, maybe that box could also be a computational storage box according to the specs and concepts that SNIA is developing, and then it fits within the overall CMSI. So, this is a straight Linux Foundation OPI talk. We also have the DPU SIG as part of SNIA, so Marty in the back helps organize that, and I'm on that committee as well. With what OPI is doing and Dash is doing, so Dash is defining cloud gateway APIs in parallel. So it's disaggregated APIs for Sonic hosts, I think is exactly how it breaks out, but you can go look that up. That's another public project. And between OPI and Dash, we thought, we haven't identified something that SNIA should do with DPUs, but maybe better defining the computational storage tie-in is something SNIA ought to do. And then whether if there's open source, maybe it can then go back into OPI as a sub-project. If there's specifications, maybe those come out of SNIA. So that's this is a lot of this sort of industry organization of these devices, and the maturity of them hit a point where a lot of the capabilities are relatively new. I mean, people have been talking about the concept for, 20 years. We've had intelligent switches and intelligent ports on switches, for 20-something years. That fad comes and goes and comes and goes. Packaging all this stuff, having it be dense enough that you could actually package something meaningful onto a card that you can drop into a server, especially at the scale that, again, this end of this year's going into next year's DPUs and IPUs can do, that's what's different. So there's a material change. There's a shift that's happened. And it mirrors the shifts that happened with CPUs, and it mirrors the shifts that have happened with GPUs in terms of hitting a critical mass of technical capability. So that's one of the changes that have happened. And the real question is whether we can actually produce common APIs or we're going to have vendor unique everywhere. That's really the question that the industry has to decide. So again, we're making the attempt to drive commonality. we'll see if it ends up. I mean, I'm optimistic, but just like everything else we do in common, across Linux Foundation and SNIA, there are significant challenges to making it a reality. All right, anything else? We still have a couple or 3 minutes. Yes, sir. So you can go to the GitHub. You can start pulling the code down. You can comment on the code. You can introduce pull requests for new capabilities that you need. You can try out the demos. You can come to the meeting and say, here's what I'd like to see. Get time in the technical steering committee meeting or the API meeting and say, hey, here's what I need to see. I looked at the APIs you have defined, and I like part of it, but it isn't far enough. I need these additional things. And then you can then propose a change. So participating is follow these links, show up, and participate. I mean, we are really trying to run it as an open source project in that sense. And again, we have, the API group has about 20 active people. Lifecycle and provisioning has about 15 active people. Like I say, we have 15 companies involved. So that's what you do. You basically will pull the code down and see if it meets your needs, and if it doesn't, come tell us why. Because that's what we need. We need people trying this and going, does it meet our needs, or all of our needs, right? Hopefully it meets some of your needs. Hopefully, but even if it doesn't meet any, we want to hear that too. And then again, a proposal for how to develop that, what you think is missing and how it should be done. So again, this will be best if we get critical mass and a true community with everyone contributing. And it helps everyone. If this comes to pass, it helps everyone. Right. Anything else? Yes, sir. Can somebody repeat? I can't. Sorry. Resource isolation and multi-tenancy. Yeah, so we know okay, resource isolation and multi-tenancy. So I referred to that a few times. This is an area where we could stand to have more contribution. So we know this is important. We know the concepts. We've defined the concepts, but we don't have a lot of work in that resource isolation and the true multi-tenancy, as I said in the earlier answer. It's a place where there's an opportunity for people to come in and do work. Yeah. I mean, again, we'll welcome any reasonable proposal or even unreasonable proposal. We welcome it all. All right. Yes, sir. Who's expressed an interest in resource isolation and multi-tenancy, and for what purpose? Some of the service provider and telcos have, because they have, especially at the telco edge, there's a need for dealing with multiple connections through those edge points. And you can do it with the standard server, but if you have hardware offload for it, that's again isolated from your standard server, you should derive an advantage. And I'm using the word should there as opposed to you will, because again, the thinking on this is relatively new. And okay, So multi-tenancy for GPUs and having the DPU or IPU manage that multi-tenancy. We have a POC with Intel Ericsson on telco offload, especially UPF offload. That's ongoing. They've come in, they've come and made the proposal, and they're going to use the APIs. IPDK, which is one of our bigger, basically sub-project, our biggest sub-project, has notions along these lines. So, but really for that one, it's again, if I was a tier 2 cloud, if I was a telco, especially at the telco edge, is where I would derive the most benefit from that. The other one is if I'm running mixed workloads with storage access, there could be value there as well. All right, anything else? We've got just 3 or 4 minutes left. I'll take any other comments or questions. All right, I'll be around the rest of the morning. And please, there's 3 more sessions coming up that have excellent content as well, and you'll see some of these ideas in practice and fleshed out. The Marvell presentation will show you real example and explain the details of how it works. Dan Daly is going to explain more details on POCs we're doing and show example test output, and please stick around. Thank you very much.